Hello and welcome to PC Retro Tech. This week I want to talk about internal PC hard drive units. So I've shown you this one before. It's the Tandon hard drive from my Amstrad PC1512. It works really well, and I'd like to have something similar for my Amstrad PC1640 and also for my IBM PC5150. Now, in the case of the original IBM PC, you have to be a little bit careful because, for example, if you put a drive like this in, which is 35 watts, it would actually blow the machine up. And the reason is that the power supply in those machines is only 67 watts. Now, the Tandon is, as far as I can tell, about 15 watts, so that would be suitable. However, I haven't been able to find anything suitable online. I did find a Plus development hard drive online. In fact, it was new old stock, and there's a video that I made recently about repairing one of these for my IBM PC5150. But that still leaves the Amstrad PC1640, and I guess I've been looking for around about a year now for another Tandon drive to come up in this form factor, and unfortunately they're just exceedingly rare. And of course I've looked for the backing plates separately, and I've even looked for entire machines that just happen to have one of these in them. That's actually how I got this one in the first place. It was there and the seller didn't know that it worked. So unfortunately these are extremely rare, and very often when people advertise computers online they say something like, "Oh, I lost my monitor cable so I can't possibly test it." And of course you know this is code for "it stopped working so I'm getting rid of it." And the main part that's going to fail, of course, is the mechanical part, either the floppy drive or the hard drive. So there's not really much point in buying those. So I started looking at other options, and I finally hit upon the idea that the late Commodore Amigas were actually PC compatible. In fact, at the end of their life, Commodore realized that PCs were taking over the world, and so they started to put IBM PC daughter boards in them so that people could actually run PC software on their computers. And eventually they started introducing the ISA slot, the 8-bit ISA slot in their machines, which were compatible with PC hardware. Now you have to be a little bit careful. You can't just go out and buy any Commodore Amiga machine and expect it to work. They had two different standards, including this, I think it's called AT slot standard, and you can see that the connector here is much wider than the 8-bit ISA connector, and it's up the other end of the board. So you can't just go out and buy a random hard drive from one of these machines. Also, most sellers don't know what's in their machine, and they also don't show you pictures so that you can tell whether it's the right thing. But in the end, I found a bunch of sellers online who were getting rid of parts from Commodore Amiga machines. And again, it's very hard to get anything that actually works, but I finally did, by piecing together parts from multiple different sellers, come up with this unit here, which is constructed from a hard drive, a backing plate which is compatible with the PC, and an 8-bit ISA controller card. And this actually works in my PC1640. Unfortunately, it was much more complicated to get this working than I thought, and so in this video I'm going to go through some of the steps that I went through and some of the difficulties that you'll face if you try and do this. So this is the first part that I bought. You can see that it's a hard drive for a Commodore Amiga 2000, and I could see immediately that it had a PC backing plate, and of course it had the metalwork that goes at the back of the whole thing to hold it together. It obviously has an 8-bit ISA card, and there's a hard drive. Unfortunately, the seller says that this is defective, and in his description he says that he wasn't able to get it to boot anymore from the Amiga software. So I knew, of course, that the hard drive itself would be faulty, but all of the other parts would be pretty useful, and the price wasn't too bad. And of course the seller had a good rating, so I went ahead and bought this one. So this is the second part that I bought online, and again you can see it's a hard drive from an Amiga 2000. But this one uses the AT slot configuration instead of the ISA slot, but it clearly is an MFM hard drive because of the two cables that you have here, and it's not listed as defective. When I read the description, the seller said that he doesn't have his Amiga anymore, so he can't test this, so presumably this has just been sitting around in a drawer for say 10 or 15 years. but he has no reason to believe that it doesn't work, and in fact he powered it up with an external power supply and the hard drive spins and there's just nothing to indicate that it's faulty. So this sounded like it might actually work, and the price wasn't too bad and the seller had a very good rating, so I decided to go ahead and purchase this. Now I did notice that there was a cable here soldered to the board, and of course that was going to be a little bit of a nuisance. But other than that, it looked like this might slot into the board that I purchased from the other seller. So I finally got the parts in the mail, and this is what that AT card looked like when I got it, roughly. I've actually changed out the hard drive here just for demonstration. First I had to unsolder this wire, and that turned out to be quite easy since it just ran under the hard drive and was just soldered directly onto the hard drive board, so that was easy to remove. But then I noticed that this slot here seems to be wired up to a connector which looks suspiciously like an 8-bit ISA connector. And indeed that's exactly what it is. The card that's in this thing is just an ordinary 8-bit ISA card. So of course that hard drive that I thought wouldn't work was actually faulty. When you start it up it makes a whole lot of clatter and then just shuts itself down. I tried it with a number of different cards just to be sure, including some that I'd purchased previously which I knew were actually working. So let me just show you what it sounds like when it starts up. So you can hear the heads there just rattling about looking for something and not finding it, and then eventually the hard drive just gives up and then it shuts down. And I guess that's exactly what I expected. It's very common in old hard drives like this, so I knew I had to use the other hard drive. So the other drive is this Rodim RO3055, and I've never heard of the Rodim brand before, but this is supposedly a 48 megabyte drive. Initially I tried plugging it into my Amstrad PC1512, actually connected it up to the board and plugged it in, and it seemed to all go okay at first, and I thought this was going to be an easy job. So I was able to run the low-level format utility, which is what pairs the drive with the card, and then I was able to run fdisk from MS-DOS, and everything seemed to be fine, but when I went to format the drive it said that there was some kind of problem. And so I needed some way to test the drive elsewhere, and so I wired it up to my 286 here. One of the things I learned very quickly is that pin 1 is usually marked by a red or a striped wire, and this matches up with a slot in the connector here. So pin 1 is at the same end as the slot. So once you learn that, you don't get these cables around the wrong way. Sometimes they don't have a piece of plastic in here to prevent you putting the cable in the wrong way around, and you can spend hours trying to figure out why your drive doesn't work, only to realize that you've got your cables plugged in the wrong way. So I connected it all up here and then powered up the 286, and the 286 BIOS in this machine has a program for low-level formatting hard drives. So it's just the normal startup for the machine, and you press delete to get into the BIOS. It takes really a long time, but eventually it'll come up. So assuming you remember to press delete, after a very long delay, this is what comes up. It says C drive error, press F1 to resume. And if you do so, it will bring up this menu and you can select Run Diagnostics. And that brings up a diagnostic program that's actually built into the ROM of the 286. And you can see here one of the options at the top is hard disk. If the hard drive is actually accessible, you'll be able to get across to that option. And the first thing that's listed there is hard disk format. So if I select this, it'll bring up a whole load of different hard drives that I can select. In my particular case, the drive isn't there, and so I select the final option, which is the user option, which is always disk drive type 47. And when I select that, it asks me to enter the number of cylinders, heads, sectors per track, whether right precompensation is present, what cylinder it starts at, and a landing zone. So hopefully you can find those details about your drive online. And there's a website called stason.org, stason.org, which has a lot of old hard drive specifications in there. Some of them are not correct, but at least my drive was actually listed there. So once you put these details in, you can go ahead and low-level format your drive. The problem I was having was that with this particular drive, every time I got to head 4, it would just stick. And also whenever I got to cylinder 612 roughly, it would also stick. Now the number of cylinders in this drive is 872 and the number of heads is 6, which is vastly more than it was sticking at. So I had no idea what was actually causing that. I do know that amongst the cards that I had available, not all of them were for the same kind of hard drive. So it seems that there were two different standards that were very, very similar, usually referred to as MFM and RLL. And if you have an RLL controller, it will work with some MFM drives, but not always. And if you have an MFM controller, it certainly won't run with RLL drives. So that could have been part of the problem, I'm not entirely sure. Eventually I settled on the Seagate ST11 controller, which is actually a controller I had previously. I do think that one of the two controllers that I bought for this project would actually work with this drive. But it was just a matter of choosing one that would do the job, and the Seagate ST11 I liked because of the software that's built into the ROM, which makes it a lot easier to low-level format a drive. So let me show you that software. I'll bring it up on the Amstrad and you can actually see what it looks like. So this is what the software looks like that comes up when you run the ST11 card with a new drive that it doesn't recognize. So I've just put a random drive in here at the moment. In fact, it's another Seagate drive, just so I can show you this operating. And this is what it looks like. It says drive C has not been installed and does not contain installation software. Do you want to install this unit? So you select yes, and it'll bring up some parameters. In this case, they're not correct, so I say no, and I don't want to abort the installation. And it allows me to then enter the cylinders and so on for this particular drive. So this is not the same parameters as for the Rodyne, but this one takes 820 cylinders. It has 6 heads, 17 tracks per sectors per track. The start precompensation is not used in this case, so you can select any value. In fact, I think what you're supposed to do is select either I think you select the largest cylinder, and you can put a drive model in. So this is actually a ST251, which is a Seagate model drive. If you don't put the drive model in, every time the machine starts, it'll say hard drive is up, and then it'll be blank. So this is where you're supposed to put the drive model in. It'll also ask for a serial number, which you don't need to give, it's not relevant. And then you have an option for interleave. Sometimes, in fact for the Rodyne drive, it told me that the optimal interleave was 3. In this particular case, it's not telling me what the optimal interleave is, so I'm going to try 3 here as well. Normally you start this off at about 6 or something like that, and you drop it lower and lower until you find one that still works but is optimal performance. And this is to do with the way the sectors are interleaved on the track, so that there's a little bit of space between consecutive sectors, so that the drive has a chance to store everything as it's reading it before reading the next sector. And if you make this number too low, there won't be enough sectors in between, and it will cause the drive to not actually function correctly. So I'm going to try an interleave of 3 and see if that works. So are these parameters correct? Yes. The next thing it asks is to enter a defect map from the actual hard drive. So hard drives of the era were supplied with a little sticker on the front of them with a list of all known defects. And in the case of my Rodome drive, there were no defects. I'm going to assume that there aren't any defects on here, but you can actually enter them in at this point. So formatting will erase the drive, I should certainly hope so, and off it goes. So one of the big problems I had with this software is that the first time I did it, I thought, okay, I'm going to just use 4 of the 6 heads, and I'm going to stop at cylinder 612 because I know that those are actually working from the experiments I did on my 286, and I also forgot to put the model number in, which annoyed me. So I thought afterwards, well, I wonder if I actually try to format this drive with this card, whether it will actually recognize all the heads and whether it will recognize all the cylinders, and perhaps everything will just work. So I tried to go back into this software again. But unfortunately, this is not completely straightforward. So normally back in the day, to get into the low-level formatting utility, you had to go into a certain address in the ROM, and the way that you did that, the standard way of doing that, was to run the debug software, the MS-DOS debug utility, and you would type in G equals C800:5. So this is an address which it should jump to in the ROM to start the hard drive low-level format utility. Now it did vary a little bit between cards, but that C800 was the most common place for the ROM to be loaded. Unfortunately for me, this stopped working. It's actually stopped working on all of the cards that I have available, and so I was unable to go back into the low-level formatting utility, any of them in fact, let alone this Seagate one. I have no idea why that is, and I think it's something to do with the computer itself, the Amstrad. Maybe there's another BIOS utility at that address, I simply don't know. So I had to come up with a way to get this Seagate format utility to come back up again. But of course, if I just stick the same drive back in, it recognizes the drive immediately and this doesn't come up. So I thought about it for a while, and I thought maybe I can trick the card by swapping out the hard drive for another for another drive, try with the other drive, then put the original drive back on again and see whether it thinks it's a new drive. And unfortunately that didn't work. It seems that the controller card actually puts the information on the hard drive itself. So if you put that same drive back in, it will just recognize it immediately. So the other option, of course, was to put in a different card, and that's what I ended up having to do. So I put in a different card and low-level formatted with a completely different card using my 286, which has the low-level format program in the 286 BIOS rather than in the cards BIOS. So this actually worked, and when I put it back into the Amstrad with the ST11 card, it did recognize that this drive wasn't known to it anymore because it had been low-level formatted for a different card, and everything went through and it completed the low-level format. After the low-level format finishes, you can see here it starts to verify the drive, and it goes through the cylinders in reverse order all the way down to 0 and checks that the low-level format has succeeded. So at this point I thought everything was fine because nothing else had actually done that, and I got all the way through the drive with all of the correct specifications for the full 48 meg drive, and there were no problems at all. So I exited out of the Seagate utility and ran MS-DOS fdisk, and I put a partition on. But then when I went to format the drive, it didn't work. And so I was basically back to exactly the point I'd been right at the very beginning, where I'd been able to fdisk but couldn't format the drive. So I scratched my head for a long time about what could possibly be causing this. I thought maybe there was some kind of incompatibility with the controller, and in the end I realized that MS-DOS 3.2, which is what I use on this machine, doesn't support partitions of more than 32 megabytes. And of course I had just selected the option to make the largest possible partition, which was of course the full size of the drive at 48 megabytes. So I put in MS-DOS 6.2, and I was able to verify that with that MS-DOS I could actually put a partition for the full size of the drive, and I could format it and everything worked. But I didn't want to use MS-DOS 6.2, I wanted to use MS-DOS 3.2, so I went back to that and immediately noticed that I can't actually remove a DOS 6.2 partition or use a DOS 6.2 partition from DOS 3.2. It's not a huge surprise in retrospect, but it surprised me at the time. So I went back to DOS 6.2, removed the partition, went back to 3.2, and I calculated what 2/3 of the cylinders on the drive would be, because 2/3 of 48 is 32, and I went a little bit under that just to be on the safe side, and then I put a partition of that size on the drive. And my idea was to then put a second partition on for the remainder of the drive, but it turns out the DOS 3.2 only supports a single DOS partition. I wasn't able to put a second partition on the drive. Anyway, I did put on a 30 megabyte partition, and then I was able to format the drive. So this is actually something that I could have done much earlier in the project, but I guess it was interesting that I learned all these other things about the drive and the cards and the cables and the DOS versions and so on as I went along. So I was successful, everything worked. I was able to actually get a 30 megabyte partition and use it from DOS 3.2, and so let me show you the end result. So of course the end result of this is a Rhodim drive with a 30 megabyte partition on it, formatted for DOS 3.2, along with the ST11 card from Seagate, and there's some cables in between. Unfortunately, the cables are very difficult to get in the correct orientation, so you can see they're kind of twisted there in order to be the right way around. There's also this power connector which goes from the board to the drive itself, and this seems to be quite standard for the day. The other thing I'll mention is that you have to be very careful with the drive itself to make sure you get the right kind. So not only do you need to make sure that the drive is compatible with the card you're going to be using, and you have to check that it's an MFM drive or an RLL drive depending on what your card will support, but you also have to make sure that the drive itself is not a 5 1/4 inch drive. So most drives from the era, even MFM ones with the two connectors and power connector, were designed to take up an entire 5 1/4 inch drive bay. The drives that go on these cards are 3 1/2 inch, so they're much narrower and much smaller. And you also have to make sure that the mounting hardware is going to be compatible. So even when I saw this online, I noticed that there were these connectors, and they were on the side like this. And just looking at this drive, it looked as if it would mount directly onto these connectors, but this turned out not to be the case. I had to remove these and then screw the drive directly onto the board itself. This doesn't seem to be any problem, but it does show that there are very many different styles of mounting, and they're not all compatible, unfortunately. Anyway, it does work, so now I'll plug it in and I'll actually show you the drive booting up into DOS. So I'm just starting up the computer here, and you can see it says please wait while the BIOS is loading. It won't come up with the ST11 installation software, but it comes up and says that C is a Rhodim 3055 drive, and then it just goes straight to booting up into DOS from the hard drive. So if I do the drive, you can see that after a few seconds it'll tell you it has a roughly 30 megabyte partition on it. So that's been a success. So now I have, finally, after almost a year of trying, a hard drive for my Amstrad PC1512. So if you like this kind of content, don't forget to subscribe and turn the notification bell on so you'll get told when a new video is uploaded, and we'll see you in a later video. Bye.